Hi guys, today we're going to talk about solving quadratic equations by finding square roots. Okay, so a quadratic equation in x is an equation that can be written in the standard form ax squared plus bx plus c equals 0, where a, b, and c are real numbers, but a can't be 0. Okay, so the reason why is if you don't have the x squared term in there, then it's not a quadratic equation. So if a was 0, you just have bx plus c, that would be a line. And so it wouldn't be quadratic, okay? The number a is the leading coefficient, and in this lesson, we're just going to look at equations ax plus c equals 0. So there's not going to be a bx term in the middle, okay? Okay, so this is a real easy one right here. You've solved problems like this before. 3x squared equals 21. So the first thing I'm going to do, of course, is divide both sides by 3. So I get x squared equals 7. And then I'm going to square root both sides. And remember, when I square root something, I get two answers. I get plus or minus, and it's going to be the square root of 7, which is not a nice number. It's an irrational number. So I'm just going to leave it square root of 7 because that's the exact answer. Okay, so square root of 7 and negative square root of 7 will both make that equation true. Okay, so most of those are pretty easy. We're going to look at a few story problems, and this one is something that we're going to use a lot, a model for when something is dropped, okay? So when an object is dropped, assuming little wind resistance, its speed increases as it falls. The height, h, in feet of such an object is given by the model. H equals negative 16t squared plus s, where h is the height at time t, t is the time in seconds, and s is the height the object is dropped from. Now, this equation only works on the Earth. So if you're on the moon or you're on Jupiter or something like that, this formula changes. Basically, this constant right here changes, okay? So this is a formula right here you definitely want to know because you're going to be tested on it a bunch. Okay, so at 9:55 a.m. on Saturday, July 28th, 1945, an American B-25 bomber accidentally crashed in the 78th and 79th floors of the Empire State Building. Hundreds of pieces of debris fell 975 feet to the street. How much time after hearing the crash did people on the street have to get out of the way? So, this is something where we want to get out the formula. H equals negative 16t squared plus s. Okay, now my start height is going to be 975 feet. Okay, and we want to know the time that people have, so that's going to be t squared. And so what's h then? Well, if you're at the ground level, basically, when's stuff going to start hitting the ground at 0? Okay, so this is the formula I want to solve. Okay, so I would add 16t squared to both sides, and I'm going to get this. Okay, I'm going to get out my handy dandy TI-84 plus C Silver Edition graphing calculator. Take 975 and divide that by 16. So t squared is going to equal 60.9375. And then I'm going to square root that. Now, the thing is yes, there's two answers to this. T is plus or minus 7.806. But remember that negative time doesn't really make sense. So this is just going to be, we're only going to use the positive answer. The negative answer is going to be extraneous. So that's how long things took before they hit the ground. Now, of course, the speed of sound is not as fast. I mean, it's speed of sound is like 780 feet per second or something. So when you hear the crash, you're going to lose about a second off of this. And of course, people, when they get startled, they freeze. They tend to freeze. And so even if you heard the sound and looked up, you'd probably have like 4 seconds to get out of the way on something like this. Okay. The period of a pendulum is the time a pendulum takes to swing back and forth. So if you don't know what a pendulum is, it's basically it can be a bar or it can be hanging on a string. So this is the pendulum right here. And this swings back and forth. Okay. So the period of the pendulum is the time the pendulum takes to swing back and forth. So basically, how long does it take to go from here to here, back to here? The period t in seconds of a pendulum of length d inches is given by the formula d equals 9.78 t squared. Now, the longest pendulum in the world is part of a clock in Tokyo, Japan. The pendulum is 74 feet or 888 inches long. What is the period of the pendulum? So what I need to solve for, I need to solve for t. So d is going to be 888. Okay, so 888 is going to equal 9.78 t squared. So at this point, I'm going to divide both sides by 9.78. So t squared is going to be 90.7975. Okay, and I'm going to square root that. And this should not be equals. It should be approximately equals because this is not going to come out to a nice number. So square root answer is going to give me about 9.53. Okay, and that's seconds. So it takes about 9.5 seconds for that pendulum to swing back and forth. Okay. So, got a little assignment here for you. There's actually 2 pages of different things that you're going to work on with solving square roots. So, have fun with that. I will talk to you guys later.